In order to use geometric construction to form the nets that will allow the creation of the 5 three-dimensional platonic solids, the students will need to utilize 4 of the geometric construction techniques that they've learned in previous years. They'll need to be able to use constructing equilateral triangles. This is covered as well in an earlier video on the 6-part division of the circle. And this constructing equilateral triangles will be used when they're constructing the tetrahedron, the octahedron, and the icosahedron. They'll also need to know how to construct the perpendicular bisector and to construct parallel lines. And I'll go over both of these constructions in this video. Finally, to construct the dodecahedron, they'll need to be able to construct regular pentagons, and this will be covered in another video as well. But by using these 4 geometric constructions, processes that they've learned in the past, the students will be able to go from a 3-dimensional imagination to a 2-dimensional imagination of the net to the creation of geometric lines that will allow them to form that net and cut it out to fold into a 3-dimensional figure. An incredible process for the adolescent. So let's go ahead and get started. Let's begin by looking at constructing the perpendicular bisector. This is something that's usually introduced in the 6th or 7th grade in the geometry lessons when working with constructions. It's a pretty basic form and one that the students pick up pretty quickly. We'll start with a line segment of any length. On this line, we'll choose a segment by identifying 2 points. Those will be the endpoints of the segment that we decide to construct the perpendicular bisector. It's important to use terms like this with the students so that they begin to understand how they can be used. Perpendicular means that it will create 4 90-degree angles. A bisector means that it will divide this segment into 2 equal parts. In order to do that, I'll take the compass and set the compass to slightly more than halfway across the segment. It doesn't have to be exact, it just needs to be more than halfway. Then placing the point of the compass on one end point of the segment, we'll strike an arc that goes through the middle and continues up to both sides. Without changing the radius, we'll put this point of the compass on the other end point of the segment and create an arc, more carefully this time, that intersects the other arc in 2 points. These 2 points of intersection, here and here, will connect with a line. And this has now created a bisection of this segment. This segment and this segment are now equal. And it has created 4 90-degree angles. Using this construction, students are able to divide any segment that they have into 2 equal parts and also to create 90-degree angles. Very important when constructing the cube. The next construction will be constructing parallel lines. In order to create 2 parallel lines, we start with a line that we want as our base. This line, we can choose a point or have a point chosen by construction anywhere on that line. Then we need to know where is the line that we would like to run parallel. That can be a point anywhere. It might be by construction or it might just be by choosing. In this case, we'll just choose another point here. In order to form that parallel line, I'll start by connecting those 2 points with a line. The next thing that I'll do is to form an arc using a compass set at any length, any radius that I'd like. From where the points come together, you can see I wasn't as careful with my original point, so I'll now make it parallel from that point of intersection. And that compass arc goes through both lines. And then I'll do the same thing, copying that arc here into space. This has created 2 new points of intersection. Now, we're going to copy that distance. This is where students will have practiced in earlier grades being able to set their compass to copy a distance. By placing their compass point at the intersection and expanding your compass, this is where it helps to have the adjustment wheel. Then I create an arc that crosses at that point. Now I've measured that distance, and I move up here. I put my compass point at the intersection that we just created, and I strike a new arc that crosses the original first. Now I know that this distance and this distance are the same, so I can connect this point and this intersection. And I've now constructed a line that is parallel to the first line. This is true because these are corresponding angles, and we know from our 6th grade geometry studies that corresponding angles are congruent. So by using this information that they've learned in previous years, expanding it to be able to solve a problem like this, and then applying the problem to be able to form the grid for a cube, they'll have used and mastered all of those techniques.